So we will recap what we have been discussing in the last 5 lectures or so. An assertion is a statement. A proposition is an assertion which is taking the truth value, true or false, but not both. Further, a proposition is a declarative statement. As part of logic, we are interested in declarative statements. We don't consider statements, interrogative statements, imperative statements, exclamatory statements, and so on. And if you look at the Greek logic and the one that was discovered by Aristotle, subsequently appreciated by George Boulier, Churchill, Alan Turing, and such scientists and so on, and the focus is on declarative statements and which is taking the truth value true or false. The reason is often we are interested in knowing what is the truth value of a given logical argument. So to talk about the truth value of a given logical argument, which is a collection of statements, so naturally we have to talk about the truth value of a statement, then compound statements, slowly to an argument. Which is why our focus is always on declarative statements or propositions and not focusing on other statements. And after looking at assertions, propositions and so on, we also saw an abstract way of representing propositions using proportional variables such as P, Q, R and so on. Then we said given two propositions P and Q, one can talk about the proposition P or Q, one can talk about P and Q, one can talk about P exclusive this, then one can talk about P imply Q and so on. So we looked at in detail what is the truth value of this, 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 and so on. Let's look at P imply Q in detail with some more examples and the insights into P imply Q and P biconditional Q. So that we will. So when we discussed propositions, listen carefully, there are two things. One is context sensitive proposition. Another one is context insensitive proposition. So context sensitive proposition and the other one is context insensitive proposition. For example, when I say 2 plus 3 equals 5, it's a declarative statement. It represents a fact taking the truth value true always. So it's a declarative statement and taking the truth value false always. And when I say Chennai is the capital of TN, so things like this, it is independent of the time, whether you talk about this today at 10 o'clock or tomorrow, or whether you discuss this topic on a Friday or a Monday or in the month of January, whether you discuss in Tamil Nadu or discuss in Andhra Pradesh. So irrespective of the place, time, and this is a proposition. So it is independent of the context. And when I talk about things like this, say today is Monday, discrete mathematics is a classical subject. This boy is performing well. This city is hot. So things like this, it depends on the context. So in our earlier lecture we said today is Monday is not a proposition, DM is a classical subject is not a proposition, and so on. And often we may have to express statements of this form using first order logic, because such statements appear frequently in our context. So what we will do, we will look at both. We will take declarative statements of this type as propositions. Although in the earlier lecture I said this one is not a proposition, and because the context, if you look at it from context insensitive definition, yes, it is not. But if you look at it from context sensitive proposition, I fix a time frame, say Monday. Fixing a time frame, so fix a time frame. So on a Monday, you see this statement, it is always true. You fix a different time frame, say Saturday, then this statement is always false. So if you fix a time frame, then it is always taking the truth value, either true or false, but not both. So it becomes a proposition. Similarly, you fix a domain, a set of people. You fix a domain, say set of computer scientists, then this is a proposition. It is always yes. And so for each of this, for example, this one you fix a set of people. With respect to that, you ask whether this statement is true or false. And you fix the city, Chennai or Hyderabad or Bangalore, then you ask this question. So fixing the context, so context sensitive, fixing the context, each of this statement, it precisely takes either true or false, but not both. So all these are propositions if you bring the context into the picture. Okay. So context sensitive proposition brings the context. So the context could be time, it could be place, it could be the underlying domain, set of people, set of numbers, set of some specific objects. So fix a time frame, that is my context, then see whether the statement is taking true or false. Fix a place, then you ask whether the statement is taking the value true or false, but not both, and so on. Okay. If you bring context into the picture, then today is Monday is a proposition. Okay. And when we discussed in the earlier lecture, it was generic. It was with respect to this definition, meaning it is independent of the context. Because we come across context sensitive statements in natural language, and we are interested in finding the truth value of a logical argument, it makes sense to bring the context into the picture so that we will be close to the reality, we will be close to the natural language. Okay. And one more important thing, when we discussed if Saturday then holiday, please note this has to be a proposition, this also has to be a proposition, and this was proposition with respect to a context. This is something like if today is Saturday, then it is holiday, and equivalently if Saturday then holiday. So which means this has to be a proposition, this has to be a proposition, only then one can talk about the truth value of the statement if Saturday then holiday or if P then Q. So we implicitly assumed this is a proposition, this is a proposition under a specific context. So examples of this type, similarly we also discussed if it rains, then I carry an umbrella. So when I look at the statement, if it rains, then it is raining outside, so context is fixed, place is fixed, and it is a proposition, and then you say I carry an umbrella. So we are interested in statements of this type, in particular proposition, by fixing the context. So for almost all examples that we come across or case studies that we come across, things like this will be there, but the dominant part will be context sensitive propositions. So we do consider context sensitive propositions as part of our discussion. So having given the picture about context sensitive propositions and context insensitive propositions, we will see some more insights into implications with suitable case studies. We have given equivalent statements as well in a couple of our previous lectures. We will see some more insights. So insights into the implication operator. For example, if I perform well in course assignments, then I will get grade S in this course. So teacher makes a statement, or teacher makes a statement saying if you perform well in course assignments, then you will get grade S. Okay. So it doesn't matter whether it is you or I. Now this is of the form, this is a proposition, perform well in course assignments, I'll get S, is another proposition. Now you have given a conditional statement combining these two, and we wish to know what is the truth value of the conditional statement P imply Q. And we have seen that the conditional statement P imply Q, so it takes the value false when the premise is true and the conclusion is false. In all other cases, it is true. Listen, it says you perform well and you are awarded grade S. So teacher is respecting this claim or whatever promise that he has made, and so the truth value of this statement, the conditional statement, is true. So supposing you perform well and you are not awarded grade S, then this claim or the statement made by the teacher is not respected. So the truth value associated with this conditional expression is false. That's what this says. I perform well, but I am not awarded S, so you are disappointed, then this statement is not respected. Okay. Now look at these two. I don't perform well in course assignments. For some reason I didn't do well, but I've been awarded grade S. Probably you would have done well in other exams, maybe quizzes and in semester. So that can happen. So I can take this statement into discussion when premise is true. Premise itself is false and conclusion may be true. For example, for some reason you would have done well in quizzes and end semester, you would have got S in this. But this statement is still true. This statement that you perform well in assignment implies getting S grade is still true. And next one says, I don't perform well and I am not awarded, and truth value of this statement is still true. So this statement can be taken into consideration when premise is true. And if you are awarded S, yes, statement is respected, you get true. And you are not awarded, which means this statement is not respected, so you are disappointed. The truth value associated with the statement is false. Okay. So statements of this is very vital and appears in different avatars in the context of discrete mathematics and in CS literature and in news articles and so on. Okay. And other thing about this is we are not interested in whether P and Q are related when we talk about this. For example, I can write a statement like this. So I can write a statement like this. If sun rises in the west, then 2 plus 3 equals 5. And these two are not related. That's one. And another thing is, premise is always false. When premise is always false, you know that the truth value of the conditional statement is always true. So this statement, so the truth value is always true. Fine. So there are two things. So truth value of P imply Q is true when premise is false. Also, I don't look at the conclusion Q. Independent of whether it is true or false, the moment you know premise is false, you can say P imply Q is true. Similarly, when conclusion is true, independent of P, whether it is true or false, the truth value of P imply Q is true. So these are all subtle things, but it's very important to know all of this. One, we are not interested in relating P and Q, they both could be any two propositions. We are only interested in knowing the truth value of P imply Q. Are they really related? No, that is not taken into consideration. The other thing is, truth value of P imply Q is always true when premise is false or when conclusion is true. When premise is false, you don't need to look at the conclusion part. Similarly, when conclusion is true, you don't need to look at the premise part. So when we were discussing P imply Q, we said if P then Q is equivalent to writing Q follows from P, and Q whenever P is sufficient for Q is a necessary condition for P, and so on. And two important things which are quite often used in mathematics, in theorem proving and so on, is this. So the other day I had mentioned P only if Q. What is the meaning of this? So P only if Q. So P is true and Q is false, So P is happening, but Q is not happening in the context. Then the truth value of P if P then Q, or P only if Q is this. Or put it in other words, P cannot be true when Q is not true. Okay. So P cannot be true when Q is not true. What does that mean? P is true and Q is false implies false. All other cases it is true. But one can also see this itself something like a conditional statement, because we said if P then Q is equivalent to saying Q when P or Q whenever P. If you look at it from this perspective, this is when Q is not true, P cannot be true. Later we will see that this one is precisely P imply Q.